All right, well, we're cooking with gas now. We've gone through all the cool simulation settings here that matter, and then combustion here. Let's move on to these subtabs now. So, for the first one we have is flames. Now, remember, to Houdini heat, the heat field is flames. So, they kind of throw these two terms around a lot. And also, you'll see that, as we discovered before, the cooling effect from the temperature field is actually what reduces the flames. Um, we don't have a lot of extra settings here to go over, except for flame height. Flame height, it's not actually like 3 units in flame height. It's talking about uh, how much cooling to apply to the field. So by putting it to like 6, maybe not so useful for like an explosion, but we're kind of doing like a jet of flame here. So the flames do kind of have a height that we care about. So by putting up to 6, it's going to allow them to remain around a little bit longer, a little bit taller. Um, that'll be nice. What else we got? We got smoke, of course. So we're emitting smoke. When are we emitting smoke? The smoke emission happens based on this here. So we have source, heat. We can choose burn or heat. Remember, burn means that right where the temperature meets the fuel is the burn field. The heat field, of course, is the actual flames themselves, which look like that. So it's going to emit smoke there. Now, not exactly there. It's going to do it based on the heat cutoff, point 2. And as this points out, it's basically when we go below this amount, so when these heat voxels equal point 0.2 or less, which is going to be along the edges, because that's where it's going to cool off, because again, the temperature field is going to apply itself to it. When it goes below point 0.2, it's no longer going to be an incandescent ball of rage and white gas. It's going to give off ash as it cools off. So that's what this is saying. As it goes below point 0.2, emit this much smoke into the voxel. Now the blend amount, basically you add that to this, so we get 0.4. So anything higher than 0.4, it's not going to emit anything. Anything below 0.2 is going to emit the full amount. And anything between 0.2 and this plus this, which is 0.4, it's going to blend in to adding smoke. And another funny thing is this create dense smoke. Create dense smoke simply means when you're adding smoke in, don't just add smoke where there isn't already smoke. Just accumulate it instead. We want to add a good deal of smoke. And let's just start with 2. So we play our simulation and see what we get. So I can kind of see it here along the edges. See these gray outlines here? That's our smoke. Now, our smoke is moving with the flames anyway, because it's being spawned more or less where the flames are, and they're both being driven by the same velocity field. So they are still kind of on top of each other. For a better idea of what it looks like, we have it here by just viewing the density. So this is the heat field, which is right on top of the density field. So the smoke is just a little bit on the outside of it. And our multi-field is, of course, showing us both at the same time. Cool. Just want to make sure that that is driven home. We could make this like crazy dense or some insane amount, and it's still going to be kind of hard to tell. It's definitely darker now, but it is still largely on top of itself. So don't get distraught that you're not seeing it. We're definitely gonna see it pretty soon. Cool. Moving on to the gas tab. Flame contribution 0.2. This is fine. I'd say just leave these for now. These are pretty good defaults. The temperature is fine. It's emitting temperature from the burn when it actually ignites. And advect fuel also not going to use. Advect fuel is pretty obvious, at least in terms of what it should do. Advect fuel basically is saying when you add your fuel field in, currently it just sticks around. And then if the temperature happens to, you know, come around and blow it up, well, that's great too. But the advex fuel actually has it move out. See how it's moving now? The velocity field is allowed to move the fuel. That could be cool for things like flamethrowers, or particularly big gasoline explosions can be cool like that if it makes sense for the fuel to travel through it. Otherwise, another normal thing, it does not. It gets added to where it is, and it blows up, or it doesn't blow up, and it just stays there. Great. So we got through all the stuff we needed. We really only changed. The only thing of significance that we changed down here was this smoke. We may even revisit it later if I find that we need more smoke. But for now, I think that's pretty good. So if we do let those continue to play, the flames, you know, the heat will die out, as we know, from the cooling field. And what's left over is that smoke. Now, again, it's all moving at the same velocity field, so it kind of looks like it's transitioning from red to this gray here. But really what's happening is simply that the flames are burning out. And what's left is the smoke. And that's what we're seeing here. So that is enough of the combustion settings. Let's move on to the shredding microsolver.